In this presentation, we're going to look at a linear algebra exercise. Now, this exercise supposes that you know about determinants, how to compute a determinant of a 3 by 3 matrix, and eigenvalues and eigenvectors, and also matters like the trace of a matrix. So let's begin. So we have this matrix here, A, and X, and it comprises 2, 0, A, top row. Now, just let's remark that that's an undetermined coefficient there. 11, 4, B, another undetermined value, 7, minus 1, and C. Okay, find the values of A, B, C. Now we're given the following pieces of information. I'm just going to scroll down there. Trace of X is equal to 0, determinant of X is equal to minus 6, and 2 is an eigenvalue of X. Just a sort of a digression, I'm going to do a little video just straight after this about how to compute the other values of the other eigenvalues based on that information there. Just a remark, A, B, and C are real values. So let's scroll down here. I've actually accidentally duplicated a couple of pages. There we go. So X, trace of X is equal to 0. So what does that mean? Well, this is the diagonal elements of X. Okay, so we have 2, 4, and C. The trace is the sum of those. So 2 plus 4 plus C is equal to 0. And my pen's jammed. And so therefore, just give me a second there to get it working again. 2 plus 4 plus C is equal to 0. And therefore, necessarily, C is equal to minus 6. Easy enough one there so far. So the trace, sum of the diagonal elements. So let's move down here. Now that's one piece of information done. Got. The determinant of the matrix X is minus 6. Now that's just incidentally the same value as C. Now I put in C here as well. I put in the value there, minus 6, rather than C. So we have found our first value. Now, how do we find the determinant of a 2 by 2 or a 3 by 3 matrix? Well, what we're going to do is pick the row or column, top row or column, and I'm going to pick the top row. Sorry, a row, any row or any column. I'm going to pick the top row because it has a 0 in it. Now, actually, the middle column has a 0 in it as well, but never mind. So I'm going to pick this row, and 2, 0, and A. Now what we're going to do is multiply each of those elements by the determinant of their minor matrices and add and subtract according to the sign array. Now the sign array is essentially a little plus, minus, plus, and so on. Minus, plus. It just alternates between plus and minuses the whole way through. Now we're going to use the top of the top row, so we're going to just disregard the others. What is the minor matrix? So this is essentially the cofactor method. There's a couple of names to it. I'm just going to call it the minor matrix. And the minor matrix is the... I've gone a bit too far there. The minor matrix is the, for example, the minor matrix of 2 is, let's subtract the row that 2 is on, and the column. What do you have left? Minus 4, B, minus 1, and 6. So the determinant of that, of 2 by the determinant of its minor matrix is 4, B, minus 1, minus 6. Okay. 0 is the next one. So let's get the determinant. I'm actually just going to sort of talk about how to find its minor matrix. Now, thing is, because it's going to be minus 0, it's not really worth finishing it off. So I'm just going to sort of leave it there like that. But it would be 11, B, 7, and minus 6. Now, because this goes to 0, the whole thing, I'm just going to disregard the whole lot. It's just sort of worth mentioning, just in case, you know, that, you know, just to get the proper sense of the method altogether, and what is usually there but is sort of dispensed with because it's a sort of easy. In other cases, if you had a 1 there, you'd have to do the whole thing. So I'm just going to dispense with that now. Just get rid of it altogether, and we'll just go straight to A. So plus A, and the determinant of its minor matrix. And what is that? Well, let's just cross off the row that A is on. I've done that already. And the column that A is on. And what do we have? 11, 4, 7, minus 1. Alright, so let's solve that. By the way, that would be equal to minus 6. That's just useful to know. So 2 times 4 by minus 6, that's minus 24. Minus 1 times B, that's plus B. Plus A times 11 minus 1, that's minus 11. Minus 7 times 4, that's minus 28. That's equal to minus 6. Solving it out, minus 48. Or actually, I'll put 2b here. 2b minus 48 minus 39a is equal to minus 6. We could bring the 48 across the other side, minus 48 across the other side. 2b minus 39a equals 42. That's as much as we're going to get out of this. Okay, so 2b minus 39a equals 42. Alright. The last piece of information is that we were told that the eigenvalue of one of the eigenvalues is lambda equals 2. Okay. Now, if you recall how to determine the characteristic equation, you do something like this. Determinant of x minus lambda I, let that equal to 0. Now, we know that lambda is equal, one of the values for lambda equals 2, and so that's one of the solutions. So we know that this is going to hold. Okay? So it's minus 2 times lambda, or 2 times the identity matrix. So what I'm going to do here is we're going to compute x minus 2I. So minus 2 there, minus 2 there, and minus 2 there. Now remember that was minus 6. So let's actually just write that in just to make it a little bit clearer. Because we know what C is already. It's minus 6. So it's minus 6 minus 2. Okay. So let's write that out again. So that's 0, 0, A, 11, 2, B, 7, minus 1, minus 8. And what we have to do is find the determinant of that. And that the determinant of that is going to be equal to 0. Okay. Now, again, determinant of a 3 by 3 matrix. What we're going to do here is take the top row, 0, 0, and A. Now, luckily, A. Let's just do this out again properly. So 0 times its minor matrix, but it's 0, minus 0 times its minor matrix. So this 0 here is the first one, this 0 here is the second one. Plus A times its minor matrix, and that's, what is that? 11, 2, 7, minus 1. Okay, and that's equal to 0. Okay, so let's work this out. A, 11 times minus 1 is minus 11. 4 times 2, so 7 times 2 is 14. So we have minus 14 there, and that's equal to 0. So we have minus 25, A equals 0. But the point is, A is equal to 0. Okay? So we have A now. A is equal to 0. We also knew C earlier on. Let's go back here. Do you remember this one up here? We're going to go back here. So 2b minus 39a equals 42. Well, if a is 0, that means just 2b equals 42. And that means b is 21. So we got all three of our values now. Let's just write it down here. A equals 0, b equals 21, and c equal to minus 6. And that's the job done. I'm going to sort of continue on this presentation now, and I'm going to find the other two eigenvalues of x. So let's end this one here. Okay,